Today you're going to set up your ECQs on page IP23. Title page IP23 Periodic Table Regions, or just PT Regions, ECQs. On page IP23, don't forget to place a page tab to mark a new set of ECQs in our notebook. Split your paper in half by folding or drawing a line to separate the left side for questions and the right side for answers. On your ECQs, you're going to answer or write down 3 questions first. On page IP23, write down these 3 questions. Go ahead and pause the video now to do that. Page IP24 will be set up for your notes, and the title is Periodic Table Regions. Set up your page for Cornell style notes with the title on top. Again, this is IP24. And separate areas for the essential question, for your vocabulary and summary at the bottom. And remember, the middle is for your notes and questions. You'll make an area for the key later at the end of your notes. This is the key for your highlighters. Your essential question is contrast metals, metalloids, and nonmetals. Number 1. The groups or families of your periodic table are defined as the vertical columns on the periodic table. Elements in a group have similar chemical and physical properties. So for example, everything in this first group, group 1, which is red on this picture, starting with hydrogen, all have similar chemical and physical properties. That means they act and behave similar to each other. For example, everything in group 1 is very reactive. And so if you were to spit on a piece of sodium, which is in part of group 1, it would probably blow up. Right? It's very reactive, and they all tend to do the same thing. Hydrogen is a gas that can also be very flammable. It's used to make the hydrogen atom bomb. So definitely unreactive, or very reactive, sorry. And all the groups here act about the same based on the column that they are in. So here's some examples. Most reactive metals are in group 1, like we just mentioned. Hydrogen, for example, again, and sodium, and so on. The most reactive nonmetals are found in group 17. For example, chlorine, as we know, is a poisonous gas. If you were to smell pure chlorine, you would probably die right away. In contrast, the noble gases found in group 18 are very stable and do not react with others. They do have a special name called the noble gases, and later on you should probably go back and highlight that. This little poster, the Keep Calm and Carry On poster, might help you remember how noble gases act. This has a little crown to represent the noble gases, and they keep calm. They just carry on, they don't do anything, they don't blow up, they don't react, they're very stable. So some examples of noble gases would be helium, neon, argon. They don't blow up very easily, they don't react, they actually don't do very much, but they can, they do serve a purpose. We'll talk about that soon. Oops. The metals are on the left side of your notes, or left side of your periodic table. They're good conductors of heat and electricity. They also have high melting points, which means you have to heat it up really, really hot to get it to melt. They're malleable, which means you can bend and pound and form shapes in a piece of metal. Ductile, meaning you can pull them into wires. So, for example, copper wires are made from a chunk of copper, but you can pull them into really thin wires. They're also solids at room temperature, except for liquid mercury, and they tend to lose electrons. Remember, there are electrons in the outer shells of or orbitals of the atom, and so they tend to lose them when they go through chemical reactions. You do not have to draw this, but this is an example. It says, "Hi, I'm copper, and I'm a metal." Some of my favorite pastimes include being malleable, ductile, shiny, and solid at room temperature. I also enjoy conducting electricity and heat. Call me! Some other examples and pictures of metals you do not have to draw. They're just examples for you. If you look here, there's silver and gold and platinum. They're often used for things like jewelry because you can pound them into shapes. So like there are many gold rings and necklaces and earrings that have very intricate designs because you can carve into them and make shapes. You can see some teeth fillings here, right, are made of metals. as well as parts of dentures. Okay? And even though you can't see on the outside, some people inside their bones have metal pins. And so metal pins can be used because you can shape them into small, thin pins and stick them into the bone area for people that have gotten through injuries. Over here are some examples of metals like aluminum and iron and copper. Brass and bronze and steel are actually not pure metals. They're a mixture of different metals blended together. We call that an alloy. Okay, so those are not pure, just so you know. Those are actually mixtures. Okay. Down here, looks like the Terminator that has melted and is ready to reform again. This is actually the liquid metal called mercury. It is the only metal that's liquid at room temperature. They used to put this in thermometers, but as it turns out, mercury can poison you, so they took that out for most of the thermometers. All right, number 3. Your nonmetals are found on the right side of the periodic table. Some qualities and characteristics of nonmetals include being poor conductors of heat and electricity, so they don't conduct heat very well, which is good in some cases. For example, when you cook with when you're cooking and you use a spatula that's made out of rubber, right, it's not gonna get hot and you won't burn your hands while you're cooking because it will not conduct the heat. They also have low melting points, meaning they can burn easily. So again, like your spatula that you use to cook, you don't want to leave it on top of the stove because it could melt very quickly. They're brittle, it breaks easily. Nonmetals don't bend and form shapes as nicely. If you try and bend it, it tends to just shatter or break. They tend to be gases at room temperature, okay? Except for liquid bromine. Some of them are solids, although most of them are gases. And they tend to gain electrons in their orbitals. Again, you do not have to draw this. This is an example. Hello, my name is sulfur. Like my friend copper, I work on the periodic table. However, I am a non-metal. Copper and I could not be more different. I take pride in being brittle and dull. I am not ductile and I cannot conduct heat or electricity. Some other examples of nonmetals here for you. Carbon, for example, can be found in a form of diamond form or graphite form, which looks kind of like a rock, but shiny and gray, and but it's not a metal. Okay? The noble gases here, like helium, neon, argon, krypton, xenon, are gases that glow under certain temperatures and certain conditions, and these again are very stable, but they're not metals. They're called nonmetals. Sulfur, we mentioned, is a yellow nonmetal, and bromine is a liquid nonmetal. So it's pretty neat because it's just liquid and definitely not metal. Your metalloids are also called semimetals. They're found on that zigzag line. You should have colored that area a little different in color. They have properties of both metals and nonmetals. They're solids at room temperature most of the time, and they're called semiconductors sometimes. They can be used in computer chips. And that's primarily their use, but there's more uses for them. Again, you do not have to draw. This is an example. Hello, mate. Metalloid silicon here. Some may say that I'm wishy-washy. Sometimes I act like a metal, sometimes I act like a non-metal. For example, like a true metal, I am ductile when heated. But at room temperatures, I'm as brittle as an old lady's bones. So sometimes a metalloid can act like a metal, and other times it will not. Some examples, this is just a picture of boron, one of the metalloids. So you can see it looks kind of like a metal, it looks sharp and hard, kind of like metal rocks. They are used often, or metalloids in general, can be used for semiconductors on computer and computer chips, used on circuit boards, like this green picture here. They're also used in lots of your bakeware because it actually protects you from the heat. And so it can be used to cook without getting burnt, and it also can withstand high temperatures and not melt like a regular non-metal, right? Metalloids are kind of neat because they can do both things. You might have these Pyrex cups at home. They're made out of silicon and boron, and so because of that mixture, it becomes a very strong glass that can withstand hugely high temperatures, and so it's very useful. That's the end of our notes. So you're going to go back and make 4 questions. There were about 4 chunks in our notes, so you should at least have 4 questions. You can do more if you want, but you should have at least 4. Remember, do not use any what questions. For your vocabulary, write the 4 vocabulary terms in the bottom left corner. And for your summary, answer the essential question in 3 to 5 sentences. Remember, your essential question was contrast the differences between your metals, nonmetals, and metalloids. And you want to number and highlight your sentences. At the end of your notes, go back and make a key in the top right corner of your science notebook for vocabulary, definitions, and facts. And then go back through your notes and highlight vocabulary words one word, any definitions another color, and any important facts that you think I'm going to ask you on the test, which you'll be getting very soon, or, well, at the end of this section, that you think will be on there. So highlight all the important stuff. And that's it for your notes.